Okay, so for this video, I'm gonna talk about the study guide for the midterm. Okay, so if you go in the root folder and you go to study guide, there's only gonna be one file here, one study guide, which has the start files and the solution files. Okay, and then an instruction sheet. So I'm going to go over this instruction sheet. I'm going to complete the study guide from start to finish, and I'm going to talk about how this is going to relate to what you have to submit on Oswald for the midterm exam. So here's how this is going to work. After you log in, okay, you're going to go into the submissions button, and when you go to me02, you're going to see the midterm exam. Now, this is not going to show up for you right now. It's only going to show up when the exam starts. And the exam starts at the time that we usually meet. So in the spring 2020 semester, we usually meet from 4 to 5:50. So at exactly 4 p.m. and after, this is going to show up, but it's not going to show up before. So make sure to hit refresh to update. And it's going to finish at whatever the finish time is for the class, which is 5:50 for this semester. And after that, you're going to lose, so you'll lose 3% per minute. So if you're 1 minute late, you're going to lose 3%, 2 minutes late, 6%, 3 minutes late, 9%, and so on. So make sure to submit before this time. Okay, so let's talk about what you got going on here. You got 3 items. Okay, so that you got to submit. So it's gonna first start out with a 3D. So the 3D sketch is gonna be located here. When you click this button, it's gonna show you a 3D sketch similar to this. So you're gonna start out by creating a new part, and you're going to build a 3D sketch per the screenshot that's going to be provided during exam day on this button. Okay? After you create the 3D sketch, you're still in the part mode. You're going to build a weldment with end caps. And that's also going to be located here. When you click that, you're going to see a second screenshot next to it that's going to show you how the weldment is supposed to look like. And if you go on the instruction sheet, it's going to summarize all that and show you the final rendering as well. You're still in the part file, okay? So once you create that on the part file, you're going to create a new assembly, and in the assembly you're going to import this weldment that you created. Okay, so it's a part. This is a part file. You are importing it inside the assembly. And inside the assembly you're going to add sheet metal, either welded or removable panels. So that's going to depend on what the screenshot shows on here. Okay? But once you have the completed assembly that looks like this, it's got the weldment with the sheet panels, you're ready to click on this button and you can fill out the mass properties. Okay? So in SolidWorks, you got to click mass properties on the search box, on the search command, and it's going to give you volume, surface area, center of mass, and you're just going to plug in those numbers directly inside the boxes that show up in this examiner. And make sure to round to 5 decimal places. You can set that up on the mass properties as well. Okay, so that's this part. This part is about the rig. Okay, you have a rig here with a schematic. So what you gotta do is read the schematic. Okay, it's gonna be something similar to this. Read the schematic, download the rig. Okay, it's gonna be something like this. Download the rig and then model tubes inside this rig. Okay, so you have 2 assemblies so far. You have one that looks like this. You have another one that looks like this with tubes that are saved inside the assembly. So guess what? That's what this second tab is. After you've modeled the tubes, you're going to click in there and add the mass properties of this assembly with the tubes. Okay, so you save that, you save that. Finally, for the third examiner, you have to upload the final assembly. The final assembly is going to be this imported into this so that it looks like that, only with the tubes. Okay, so this is what you import. You import this with the tubes, all virtual, right? Every piece has to be virtual because, again, in SolidWorks by default, part files are saved to an external directory. To avoid that, to embed the parts inside the assembly, you got to right click and make virtual. So the final assembly gets uploaded in here, then you hit submit, you wait for the progress bar to finish, and you'll be done. Okay, and all of this is done in class. Okay, there's no take-home part. You get an hour and 50 minutes, and keep your eye on this due date, and try to complete all 3 steps within that time. So what I'm going to do now is actually do this exam from start to finish, the study guide. So let's see here. Let me turn off these features. Make sure to update your units and make sure this is ANSI and units IPS, or you can change it here. Okay. So, alright, we have to create a 3D sketch. So I'm just going to start with the top plane, and I'm going to build a 3D sketch on here by starting out with a center rectangle tool. Okay, make sure to hit escape, and I'm going to set all these for construction, you see, so that they, because this is the floor, and the floor doesn't need to be active. So, okay, I'm just looking at this rendering here, and I can see that these are 17.5 each, and right now it's not fully defined, so I'm going to look to see what's bold, and looks like along Z is bold, and now what we have is a fully defined. From here, I'm going to start building the legs. Again, this is all happening in one 3D sketch. I don't want to see 2 or 3 3D sketches. You only need 1. Okay, so remember, when you're working in the 3D mode, try to rotate a little bit because it can be kind of confusing where you're pointing. Alright, we need 2 more squares because there's one for the floor of the machine and one for the floor of one for the floor of the machine and one for the ceiling. Let's see this. Ooh, this is not okay. So let's clean this up a little bit now. Let's make all these equal. There are many ways of doing this. Okay, there's just one way. Let's make these. Okay, that looks good. Let's try to drag this. Okay, that looks good. So, and they need to be fully defined, and I can do that by adding a dimension here. So it says it's 3 inches from the bottom, and the top is 26. Ooh, I forgot one more square. This one's for the table. There's a table here. Try to snap to that yellow line also. I know it can be kind of difficult, but try to do your best. Okay, just like that. And then add a smart dimension. Okay, 13. Alright, looks good. So as you can see, everything's black, everything's fully defined. This line here, it's actually midway. So you don't need any dimensions for that, just snap to the center. And you are done with the 3D sketch. Alright, what I'm going to do now is turn this 3D sketch into the weldment that you see here. So for that, we are still in the part file, but we got to turn on our weldments. And we got to start the, let's see. Okay, there we go. We have to get out of the sketch. Okay, so here's the sketch. Now these are active, and it starts with the structural member button, and it's going to be 2 by 2 by 0.25. You can read all the descriptions here. It's going to tell you all these specifications. So now we're going to add groups. Remember to stay consistent with your groups, otherwise you'll get problems. New group for the floor, and new group for the table. And new group for the ceiling. I'm just gonna add another group for this piece. See what we got. Oh, okay, looks good. So we don't really need the construction lines anymore, so I'm just gonna hide all types. And I'm going to trim and extend. As you can see, this goes out to here. Just gonna switch this. There we are. Okay, one there. If you hit enter, you may be able to repeat last command if it's configured like that. If not, it could be Y, if you hit the Y key. For me, it's the enter. Otherwise, just keep clicking that button. Okay, there it is. Enter this one up to here. Okay, 1, 2, 3, 4. All right, those look good. Let's add the end caps. All right, to add an end cap, we're just gonna click there, and let's see, we got radius 1/2 inch, thickness 1/4 inch. So we're gonna click here, add a coordinate treatment of 1/2 inch, and we're gonna click. All right, there's the end caps. Looks good. So let's see, that looks good. All right, so I'll tell you what, this weldment is good, so I'm gonna save it now. Just gonna call it weldment. Okay. And we need to bring this on an assembly, so I'm gonna create a new assembly now. And I'm gonna bring this weldment. And again, there are easier ways of centering this. If I click on this and I just click OK, see, it centers it automatically. I just don't like doing it like that. I prefer to do this using the mates. But essentially it's the same thing. The other technique was fixing it to the center. This one is mating the planes. I just feel like I have much more control over my assembly. But pick one or the other. I want you to always center your objects, okay? It's gotta be centered. It can't be floating in free space. What I'm gonna do is hide these construction lines now. And I'm going to save this as a weldment. Okay, just save this assembly. Okay, good. So now we are ready to add the sheet metal. So I'm going to start with the welded panel by clicking new part, so that it builds it inside the panel. Okay, so new part is when you build inside the assembly. Insert components is when you import it from an outside directory. So I'm just going to snap to each corner so that the line is defined within the weldment. Okay, because that's the whole point of top down, is to use the surrounding assembly to define the object. So if you notice, I did not use any dimensions to create that sketch. So anyways, here's my sketch. Let me go back to part mode. I'm just going to click edit part mode. And here's my sketch. I need to turn this into a panel. So what I'm going to do is I'm going to turn on my sheet metal. And I'm going to start out with the base flange tool. And this time we're going to use 1/8. Okay, 1/8. So everything is 1/2 what we did during the exercises. So let's see, here's our panel, but I'm still not sure like if I extrude in the correct direction. So I'm just gonna move. Okay, as you can see, this is flush, which is what I wanted. So my extrusion was in the correct direction. And there's the panel. Okay, so what I'm gonna do now is right click open part. And again, I just like working in this environment. It just makes it easier. So this is a welded panel. So we need flanges. Okay, so let me see. Let me turn on sheet metal. Let's look for flanges. And we need one here, one here, one here, and one here. So since the beam is 2 inches, the length is going to be 1 inch. It's always halfway. Okay, so let's first double check to make sure we are in the correct direction. And as you can see, we are in the correct direction. The flange is pointing inward. So let's add the reliefs. Okay. You gotta go in here and change each of these sketches. And just drag this in. So again, not every fab shop needs this. And again, this is really just to help you understand how to modify a flange. Okay. Because every machine is designed differently. For instance, a computer case has a really bizarre sheet metal layout. There's like a bunch of like cup-shaped panels that kind of hug each other and they form the box, which is a very... If you ever take the time to study those, there's quite a bit that goes into that. Or even like a smartphone, if you really spend the time to look at a smartphone, you'll notice some really intricate details in sheet metal. And if you spend the time to understand all these tools, you can pretty much create all of those features without a problem. So all those features can be done. Right now I'm holding Alt and clicking the arrows just to give me that incremental rotation. So anyways, that is how you add a relief. Again, I try to select a line instead of a point. It's just a much stronger connection. So there it is, nice low relief on each, and let's take a look at the final result. And there it is, there's the panel. Alright, we're going to hit save. Now we're going to work on the removable panel in the front. So here's what I'm going to do. I'm going to do the same thing. I'm going to insert new part on this surface. And we're just going to create a box. Make sure not to snap to anything. Okay. Think of it like a spider web. Okay, a spider web. It'd be hard to move a spider web if you have it attached in certain locations. You don't want to do that. Okay, this is supposed to be 1.5, which is 3/4 of the way inside the weldment. Okay, just like that. So it's black, it's fully defined, it looks good. But let's see here, what else? Okay, so we're going to exit out of the sketch and we're going to turn that panel, right? Okay, I'm still in part mode because it's blue. I need to be in, okay. Now let me turn the sketch. Okay, see, I got to turn the sketch into a panel. So it's going to be also 1/8. And let's exit out of the part to see. Actually, I do want this to extrude the other way, so I'm going to edit this feature and reverse the direction. So let's see what we get now. Okay, that looks a little better. Okay, from here, I can open this and add a hem. It's going to be a fully closed hem. It's going to be 1 inch long. And it's going to go inside just like this. So let me go back to the assembly, make sure it's, yeah, looks good. It's on the inside. And then I can now add the reliefs here as well. So here's how this works. You move the dot. You put a dimension. And you do the same thing on the other side. Okay, so as you can see, I've added the reliefs on all three. It's also a good idea to include a fillet on each end. Let's see how long it's supposed to be. Radius, 0.75 radius fillet on each corner. Okay. So I'm going to hit save, and I'm going to go back to the assembly. Okay, and now we're ready for the smart fasteners. So first let's double check to make sure these two are turned on, because they don't turn on by default. So those are the toolboxes. It should be on the documentation for sheet metal, so that should be alright. So we first need the whole series tool, and we're going to hover over there. Yep. and kind of snap. Well, if it doesn't snap, just click somewhere and then try to get the hover over. I know it gets kind of difficult sometimes. So sometimes what you gotta do is rotate your mouse till there's nothing behind this fillet and move. So you hover over the edge and then it starts to show up. See that center starts to show up. Or you can do select other, that can also work. Okay, and I'm gonna do the same thing here. There, see? So that looks pretty good. Let's see what kind of hole this is. That's the second one. It's supposed to be 100 and it's supposed to be 1/4 of an inch. So 1/4 of an inch, 100. And then everything else should be automated. This is really all you needed to spell out. So click OK and let's see what we get. So let's click OK. Alright, there it is. Okay, so once you have the whole series, you can fire up the smart fasteners. Again, alright. Just hit populate all. Okay. So it's going to generate the hardware, which is good. And then, since this is a symmetrical object, we're going to mirror this to the other side. So we're going to do that using the mirror tool. And let's see, the mirror tool is here. So we got to pick five items, the panel and the 4 bolts. Okay, and let's see what we get. There we have it on the other side. I believe we made a little mistake here. This one's supposed to be the other way. That's alright. We're going to fix that. That's the nice thing about top-down assembly, is that you can modify one thing and everything else updates. So let's see if we're lucky. Oh, look, no errors. We got a little lucky there. Let's go back to the assembly. Now we're in good hands. You see, now this bar matches the panel. There's no panel on the side. The panel matches the T that you see here. So we are done with the first part of this exam. So once you have this, or whatever the screenshot shows on Oswald, whatever shows up here, you're ready to get the mass properties. Okay, mass properties. And there's the numbers. Okay, if you want 5 decimal, just type in 5. So here's volume, surface area, center of mass. So you fill out the information here on this one. So now what I'm going to do is work on the second part, which starts with the schematic. Okay, so you have a schematic here. For the study guide, it looks like this. And the first part is really to understand what's going on. Okay, and understand how it relates to the rig. This is the rig, this is the schematic. So the rig looks like this. So first thing you might want to do is look, alright, there's a control valve, there's a quick disconnect, and, you know, type in valve. Let's see, okay, so that's what the valve looks like. Let's click disconnect. That's how the disconnect looks like. So once we understand how the symbols correlate, we gotta understand how they're connected. For instance, we see that the quick connect is connected to the control valve, and the control valve is connected to the speed controllers. So now that we know that this fitting is connected to that. So remember, yellow means outlet, blue means inlet. Again, this is just a color coding I used for these exams. In the real world, obviously, they're not color coded. You have to read the data sheets. But for this exam, that's the protocol we're going to go with. Okay, so again, we're going to use top-down assembly. So again, a core component of this class is understanding top-down assembly. This is why we use so many top-down assembly tools. But we're going to use it again for the tube. So I'm just going to, I'm creating a new part, and for this, it's okay if it's a 2D sketch because this one only goes one direction. I'm just going to create a tube like this. I know it's kind of hard to see, but the fitting goes right there. Okay, I'm going to make this horizontal, and I'm going to move this in some and add a fillet. Fillet here, fillet there. Yeah, let's do 0.5. 0.5 should be good. Click OK. And since I touched the center of that piece, the concentricity should already be there. Let's take a look at what we got. Yeah, that looks actually pretty good. That looks how it's supposed to look. And so I have the profile. I'm sorry, the path. Now I need another sketch, which is gonna be the profile. Okay, so now that I have the path and the profile, I just control select both. I hit swept, boss, and base, and I click OK, and as you can see, I get a tube. Now again, remember, on the newer versions of SolidWorks, you will get an option to say circular path. So if you click that option, you don't need a circular profile. Okay, the option will say circular profile. I mean, for piping and tubing. So if you get that option on the version of SolidWorks that you use, you don't need to create the circle that I just did. But if you're using an older version, you have to create it. Okay, so that's what it looks like. Alright, this other one's going to be a little bit more complicated. We're going to click new part, and I'm going to start it over here, just because I feel like it makes a lot of sense. Alright, so now that we are initialized, as you can see here, I got to exit out of this, because by default it creates a 2D sketch. I don't need a 2D sketch, I need a 3D sketch. So I got to bypass that, create a 3D sketch. And now I'm going to go ahead and draw this profile. Okay, so I'm hitting the tab button, remember? That's how you switch planes. And I'm gonna be very careful not to snap to anything, and I'm just drawing the profile of how this thing is gonna come together. So I'm gonna bring this in, and this point is going to be concentric about that. And this point is going to be concentric about that. And then this line is going to be collinear. And this line is going to be concentric. This one's going to be concentric to that. Okay, so that's how that looks like. Then make sure this goes in. Because again, this is presentational. When you send this out, you just send the schematic and the rendering, and that's what you do to communicate a hydraulic system. Okay, so now we're going to add a little fillet for laminar flow. Alright, to improve the laminar, to improve the flow. But you gotta be careful, you can only select the dot, the point to get this going. Okay, so now that's good. I'm just going to bring this in a little bit. I feel like that's a little... See, sometimes it's hard to do things. It's hard to modify some of these lines. So what I end up doing is just drawing them again from scratch. Okay, looks good. It goes all the way around. I do need a circular profile though. So maybe, let's see, am I still in the sketch? I am still in the sketch. So I'm going to create a circle now on that surface. And it's probably, ooh, no, I don't want that. It's probably gonna be, maybe 0.25. So here's the tubes, and we're gonna click on swept boss base so we get a profile here. So there's the tube, and there it is. So I'm gonna save. Okay, so now that's good. It's all saved. Let me save this. Remember, save this as another file. So I'm saving it as a slider. That's just the name. So now that you have this, by the way, in case this is not clear, this is a rodless cylinder. There's a magnet inside that moves. See, this is the symbol for it. There's a magnet inside that moves this slider. So when you energize, you move the control valve here. It energizes one side, so the slider moves there. You energize the other side, and moves the other way, and that's called a rodless cylinder. So anyways, that's what it does. You move this handle, this slider moves back and forth, and this is where the supply is located. So, so let me save this. Okay, so this is good. Then you can do the mass properties. Okay, you do your mass properties, and you fill out this second piece. All right. So finally, for the last piece, what you got to do is go back to your master assembly, and you're actually just gonna don't worry about that bolt thing. Just hit cancel. It's still gonna work the same. You can either do insert components, or you can just drag this whole thing like that. So you can do it either way. Okay, and then what you gotta do is look at the screenshots and make sure that, you know, this logo matches with this and that. There's really only one way you can put this thing in there, so hopefully that should be pretty self-explanatory. I mean, when you put this in here, you can see that it can only slide there, this can only go there, this can only go up to here, okay, and as you can see, you know, you can't move this anymore. So that's the completed assembly, but you have to test it now. You have to make sure everything is virtual. So for example, let's say I were to save this. Again, forget this is just some glitch in SolidWorks. Hit cancel when it talks about the bolts. But anyways, I'm saving this, but you're not done yet. For example, if I go to where I saved this, so let me show you what I mean about the make virtual. Let's say I create a new folder here, and I move this in there, and I move that in there. Let's see what happens when I open this. See, everything's gone because it lost the reference. It lost the link to the external directory. So that's what I'm gonna get when you submit a assembly without making virtual, and you're gonna be graded accordingly. So what I want you to do is instead make virtual. Okay, so let me close this. Let's open this again. Let's see what we get. Okay, everything's there. Now you're gonna make virtual. Right click, make virtual. If it doesn't say make virtual, it means it's already virtual. So right click. Let's see, is this virtual? Looks like it is. Let's see what about this one? Yeah, this one I built inside of it, so it's good. The slider is not, so it's gonna make virtual, and then it should be okay. So there it is, and then everything else is fine. So now let me hit save. The file size is gonna increase now. It's probably tripled in file size. But now let me close this. Let's go to this file. Let me do that trick again. I'm gonna move all these pieces. Let's open this weldment. So now the external directory is broken, but as you can see, all the pieces are still there because I made them virtual. And this is what you submit, okay? You submit this after you've tested it, okay? So you submit this into the last piece, which is the browse. And once you select that file, it's an SLD ASM. You select the file, make sure it's under 18 megabytes. You're gonna hit submit. And you'll be done with this exam. Again, remember to do that before the time that's indicated here, and that's what you got to do for the midterm.